Hello guys, welcome to today's class. In today's class, we'll be discussing chain rule of differentiation, right? And in this class, we'll see how simple it is to differentiate various functions using the chain rule. Okay, if you have a function y equal to v of u of x, if you have a chain function like this, where u of x is contained inside v, so this is y equal to v of. So when you have a chain function like this, you apply chain rule. Now this can also be called function of a function. And please, it is important you note that this is not product of functions. These functions are not multiplied. Instead, this function is chained inside. It is contained inside the v function. Alright? Now, if you have product of function, if you have y equal to v times u, where v and u are all functions of x, you definitely know that you are going to apply product rule to differentiate this, to find the y, the x. But in this case, we apply chain rule because this is a chain function, function of a function. So if you have this function, how do we find the y, the x? How do we differentiate this? To find the y, the x here, first of all, you need to identify the inside function, the inner function, the function of x. I will have to differentiate u with respect to x. I will find du dx times, then I will differentiate v with respect to u, dv du. So observe closely, I will differentiate this with respect to this, then I will multiply with the differential of this with respect to this. And at the end of the day, I'll be able to find my dy dx. That's how we perform the chain rule of differentiation. What if I have a chain of function like this? Y equal to w of v of u of x. This is still a chain function, but we have a function of another function. This is a triple function. Alright? How do we find dy dx here? To find dy dx is also very simple. Dy dx. Simply identify your innermost function, the u of x, identify u, identify v, identify w. Alright? And then differentiate this with respect to this. Differentiate u respect to x. You have du dx times differentiate v with respect to u. You have dv du times differentiate this with respect to this. You have dw dv. When you multiply these three chains, you will find dy dx at the end of the day. Enough of these explanations. Let's go into some practical examples to better understand how to apply the chain rule of differentiation. Okay, let's look at this example. We have y equal to sine of exponential x squared. Alright, now if you look at this is a chain of functions. The sine function contains the exponential function. The exponential function contains the algebraic function. These functions are chained. They are not multiplied. This is now sine times this. So you don't have to apply product rule here. This is sine of. It means this is composed inside the sine function. And that's a chained function. Okay. So how do we tackle this problem using the chain rule? First of all, we identify the various functions. We go to the innermost function. We identify the innermost function, which is a very direct function of x. We identify x squared. So our u is the x squared, the innermost function. Then after u, we can call this v. V becomes exponential. The exponential is the v, but because this is already u, we can say exponential u. And then we push out, we identify this one. If this is u, v, w, u, v, w. So w becomes sine of something, but this exponential is v. So we can say sine of v. Right, let's go about this again. We identify the innermost function, we call it u. The next function to it, we call it v. And the last function, we call it w. Right? If we write this as u, then this will be exponential u. Because this is already u, we call it v. And then this will be sine v, because this is already v. We call this w, right? And then if you can identify this, the next thing is to differentiate them. I will have to find du dx. If I differentiate x squared, I will have 2x, right? The next thing is to find dv. I will differentiate v with respect to u, alright, because it's a function of u, dv du. If I differentiate exponential u, it is still exponential u. Okay, and then I'll differentiate w with respect to v, right? With respect to v. If I differentiate this, I'll have cos v. I've differentiated. The next thing is to find my dy dx by multiplying these derivatives I've made so far. So dy dx will now be the product of these derivatives I've made. I'll multiply them. That is du dx times dv du times dw dv. And this will give us du dx is 2x, dv du is exponential u, dw dv is cos v. Alright, but remember, I started these functions with x. They are off, they should go back to functions of x. So this u, I'll have to convert it to be a function of x. V, I also turn it to be a function of x. So if I go here, this is 2x, exponential u, u is what? X squared, cos v. V is what? V is exponential u. So this gives me exponential u. But this is still in terms of u. It is not yet in terms of x. So I'll keep on simplifying this. If I multiply this, I have 2x exponential x squared times cos exponential. Then my u now is x squared. X squared. And this will give me my dy dx. And everything is in terms of x. And that's my dy dx. Okay, let's also look at this very interesting example. Y equal to ln of sine of exponential x. This is a chain function because we have the ln function containing the sine function, and the sine function contains an exponential function. Alright? So this is a function of another function. Triple function combined. Okay, so how do we find dy dx? We need to apply chain rule to find dy dx. The first thing we do is to identify each of these functions. Alright? So the innermost function, which is exponential x, it's a direct function of x. We'll call it u. U is exponential x. And then this is our u. This will be v. This will be w. If you have more function, you can keep on naming them. I can have z and so on. So this is my u. This is my v. My v now, which is sine of something, will be sine of, but this is already u, right? Sine of u. And then I need to identify u, v, w. W is the next one. Let me call this w. W is ln something. Ln what? It will be ln v, because v is the whole of this. I'll call it ln v. So the first thing is to identify this function and name them accordingly. And then the next thing is to differentiate them. I will differentiate this with respect to x, right? Because this is depending on x. Du dx. If I differentiate exponential x is exponential x. Now this is a function of u because it's depending on some values of u. So I'll find dv du, right? Dv du. And if I differentiate sine u, I will have cos u. Cos u. Because if you differentiate sine x, is cos x. The same way you differentiate sine u, it will be cos u. Alright. So if I differentiate this, what am I going to differentiate this with respect to? I'll differentiate with respect to v because it's a function of v, right? So dw dv ln v will be 1 upon v. 1 upon v. Because if you differentiate ln x, it's 1 upon x. So if I differentiate ln v, it will be 1 upon v. And this is our derivatives. Next is to find dy dx. To find dy dx, we'll simply multiply all these derivatives we've made. We'll change them. So dy dx will now be the product of all these chains we've differentiated. So it will be du dx times dv du times dw dv, and then substitute the values of these derivatives. So if we substitute this, we have exponential x, dv du is cos u, dw dv is 1 upon v. But I need to convert all of these functions to be in terms of x, right? So I have exponential x cos u, but u in terms of x is exponential x. I'll replace it back to exponential x. The next one, 1 upon v. 1 upon v itself is sine u, but it's still not in terms of x. U itself is exponential x. I have to keep on writing this, simplify it to be in terms of x, but I can directly write everything here because of space. So for v is sine u, but u itself is exponential x. I'll have exponential x, and the whole of this will be my dy dx. I just need to multiply this and then divide by this, and that's my dy dx. Okay, let's also look at this very interesting example. We have y equal to exponential sine ln x squared plus 2. Chains of functions, right? You see, exponential function carrying a sine function containing a logarithmic function containing an algebraic function. Chains of functions, alright? How do we differentiate this? Like I said, we go to the innermost function. You know, the biggest function here is the exponential function, right? We go to the innermost function, we identify it to be u, because it's a direct function of x, u of x. It's a direct function of x. So our u here will be x squared plus 2, right? After this innermost function, the next function is the logarithmic function. If this is u, this will be v. You name them accordingly. My v is a logarithmic function, ln something, which is ln u, because this is u. I'll go again. After u, v, w. W is what? Sine something, sine, but it will be sine ln something. So that's v. V is ln u. So it will be sine of v. And then u, v, w, we can now call this one z, right? Z will be exponential, because the whole of this is exponential. Exponential something, sine. Sine is already w, so exponential w. So you see, the first thing is to identify these functions, name them accordingly. And then after that, we differentiate. To differentiate this, because this is the direct function of x, we are going to differentiate with respect to x, right? So if I differentiate this, I have 2x. This is depending on some values of u, right? V is a function of u. So we differentiate v with respect to u. If I differentiate ln u, I have 1 upon u, right? So the next one, w, is a function of v. So I'll find the w dv. You differentiate with respect to the independent variable. So I'll differentiate w with respect to v. If I differentiate sine v, remember, differential of sine x is cos x. So differential of sine v will be cos v. Next, I'll differentiate the z with respect to w. So I'll find the z dw. Differential of exponential x is exponential x. So differential of exponential w will still be exponential w. So I will have exponential w. I've differentiated each of these functions. Now, I can now find my dy dx by simply multiplying these derivatives. As simple as that. So my dy dx will now be du dx times dv du times dw dv times dz dw. I will simply multiply these derivatives. Now, but I need to make sure that at the end of the day, all the simplifications I will make will be in terms of x. Alright? So if I start making my substitutions, du dx is 2x, dv du is 1 upon u. So that's 1 upon u. dw dv is cos of v. And the next is the z dw. The z dw is exponential w. I will go start making my substitutions. This is 2x 1 upon my u. I'm trying to replace everything to be in terms of x. My u is x squared plus 2. X squared plus 2. My cos v. V here is ln u, right? So that is ln. But my u itself is x squared plus 2. X squared plus 2. I've replaced this. Alright, then I'll go to exponential w. We will gradually return this w to be in terms of x. So w is sine v. Sine, but this v should also go back to be in terms of x, right? Sine v itself is ln u. Ln, but u itself is x squared plus 2. X squared plus 2. We close this. And this will give us our dy dx. Okay guys, I told you guys that chain rule is actually a very simple rule of differentiation. Now let me give you guys some shortcuts on how to tackle chain rule problems. Now this same problem, as complex as it might look, let's see how we can find our dy dx very direct on this. Alright, so to find dy dx, we are going to approach it gradually. The first thing, go to the innermost function. This exponential sign of ln of something, the innermost function. I will start from the innermost function. I will differentiate this with respect to x. If I differentiate x squared plus 2 with respect to x, I will have a 2x, because the derivative of x squared is 2x and the derivative of 2 is 0. I have 2x. I'm done with this derivative. So I will now push out to the next function, which is ln something. Because I've taken care of this, I can now differentiate this directly. So if I go to ln, I will differentiate ln something is 1 upon that value, right? Remember, differential of ln x is 1 upon x. So differential of ln anything should be 1 upon that value. Okay, now I'm done with ln. I'll push out to sine. Differential of sine something is cos of that value. Cos of that whole value, which is ln x squared plus 2. I'm done with the sine function. I'll push out again. Differential of exponential something is still exponential that value, right? Because differential of exponential x is still exponential x. Differential of exponential is still exponential that value. So I will have exponential sine ln x squared plus 2. And this is my dy dx. Very direct as this. Okay, let's still look at more interesting examples on this so that we can thoroughly understand chain rule. Because at the end of the day, you should be able to tackle any problem involving chain rule. Okay, let's look at this one. We have y equal to exponential x squared plus 2x plus 1. Okay, so this is an exponential function, but it has a chain of algebraic function up here. So we're going to differentiate this one first, because that's the innermost chain. We'll differentiate this, then we'll differentiate this. So let's find dy dx. Dy dx is a very simple one. Go to the innermost function, differentiate the whole of this. If I differentiate this, I will have 2x plus 2, right? Differential of x squared is 2x, differential of 2x is 2 times. Now I'm done with the innermost function. I will now come out. Differential of exponential anything is exponential that value. So I'll have exponential x squared plus 2x plus 1. And this is my dy dx. What if I have this? Y equal to ln sine exponent x. Something like this. Let's look at this. This is y equal to ln of sine of exponential x. To simply differentiate this, we start with the inner one. So let's find dy dx. We go to the innermost function. Differentiate the inside function. If I differentiate exponential x, I have exponential x. I'll push out. Differentiate sine something is cos that value. Push out again. Differentiate ln anything is 1 upon that value. 1 upon sine exponential x. And this, if I simplify this, is exponential x cos exponential x, because this times this times this is this, all over sine exponential x. I can also keep this as exponential x. Cos exponential x over sine exponential x is cot exponential x. And this is my derivative. So guys, if you are given any function that is chain functions, it's a very simple one to tackle to find dy dx. Simply identify the innermost function. We identify the innermost function, differentiate in respect to x. And then you push out, differentiate the next one with respect to the previous one. Differentiate the next one again with respect to the last one you just differentiated, and then multiply. Right? So it's just a simple one, exponential x, differentiate this respect to x, times differential of sine is cos, times differential of ln is 1 upon that value, and then multiply. That will be your dy dx.